Akoto. I know you are there. Come on, Akoto. Come see Premi.
Hello, Alpha. Yeah, the landlady is here today too. She's harassing me this morning. Yes, come and see how I'm sweating.
Well, if I catch you,
Yes, the number I sent you the last time. Yes, use the JuPay app. It will come right now.
Hey, bra. Ah, so I'm sick of mommy. Give me my money. Me, Jimsika.
We didn't know. What your JuPay is here? Yes, Canada, your JuPay. JuPay is the best money transfer app that is used to send money directly from the US to Ghana free of charge. They have the best rates in the market and they are very competitive. And until a scanner can abroad.
Let me see. She's never had a toothache before.
There might be a cavity. Don't you use Pepsodent?
We used to, but I'll try the new one.
Ah, that's why.
But doesn't every toothpaste give cavity protection?
Not really. Pepsodent's Cavity Fighter repairs tiny invisible holes to give 10 times stronger teeth. Will you trust Pepsodent?
Definitely.
Pepsodent, 10 times stronger teeth.
Use Pepsodent's Cavity Fighter.
Okay. Good afternoon, everyone. Good afternoon, everyone. So after 2 days, we are here, the grand finale. So welcome to all those that are joining us live on Facebook and all streaming channels. Welcome to the Sci-Tech Challenge. For the past 2 days, our top 10 schools have been coming up with agri-tech solutions that they truly believe can boost Ghana's economy. Now, the rules of the challenge: all schools are to build their solutions from scratch, from raw materials, and then they have 9 hours to complete building the model. After which, we will have a live demonstration. During this live demonstration, each school will be asked to present their project, do the demonstration, and answer a few questions. Now, invited guests who are joining us today, as we go around the various schools, you can come with us. We'll open the questions to everybody, but then it will only be the judges that will be scoring as we go along. We have our consultants here. We have Mr. Nehemiah, we have Mr. Michael Mensah, and myself. And then we also have some guest judges with us as well. We have Mr. Samuel Adjo from Prime Time, who will be joining us. We have Mr. Yakubu Yusuf, who will also be a judge. He's our MC extraordinaire, but has a technological background. And he's been doing this with us for the past 3 sessions. And then also joining us from Academic City, our Vice President for Academic Affairs, who is big on entrepreneurship, Dr. Senna Agboja. So you have all these 6 people judging and awarding marks as we go along. Now, judging criteria, we have 2 different criteria that we'll be looking out for. The consultants are going to be looking out for creativity and innovation, how unique and original your work is. What new or innovative step did you use in the design and build? An effective use of materials and resources, and your ability to adapt when challenges came up. So these are things we have been observing over the past 2 days. They will also be looking at technical complexity, the number of technologies involved, high-tech versus low-tech. We'll be looking at the level of complexity, discrete activities that your device will be doing. And as we told you all yesterday, if you use 2 students throughout the competition, then you get an additional bonus 2 marks. We will also be looking at sustainability. Is there marketability for this? Manufacturability, ease of use, and aesthetics. And the consultants will be looking out for teamwork, evidence of your strategic planning to achieve your target, how well you work together over the 2 days, your passion for your job, your team communication and collaboration. Your procedure will also be analyzed. We'll look at evidence of logical and critical thinking, evidence of good planning, i.e., did you request all the right materials, or did you start requesting materials at the last minute and ad hoc? And we'll be looking at how you executed the project. And then we will be valuing the final presentation, which will look at the successful demonstration, effective communication and presentation, and ability to answer your questions. The judges, the external judges, who are only joining us for today, will be evaluating you on the following: creativity and innovation, how unique and original your work is. They will be looking at it from a sustainability angle. How marketable is your product? How manufacturable? How affordable? Ease of use, aesthetics, how it looks. And finally, they will be evaluating you on your presentation, if you have a successful demonstration, how you are able to communicate effectively, and then your ability to answer questions. So we will start going around the room. Each school has how many minutes to present? 10 minutes. So you have 10 minutes to present, including your demonstration. And then after the 10 minutes, we will take questions as well. 10 minutes for your presentation and demonstration, after which we will take questions as well. Thank you very much.
Hello? Hello?
Hello?
Memorial. Over to you.
Thank you very much. Hello and good afternoon. My name is Elfrida Hammond and I'm here with
Aggrey Joseph Elipli.
and
Being Samuel.
and we are representatives of the Aggrey Memorial Robotics Club. Today we have for you the integrated farming system. Now the integrated farming system will take the farmer through his planting process all the way till harvesting. Now after he has harvested, he can then store his crops or dry his crops in the dryer. This way they can be preserved for a longer period of time. Now, what brought about the idea for us to put all this together? According to our research, although Ghana has a lot of potential when it comes to our agricultural sector, we still import a lot of our foods. Now, a report from the Ghana Statistics Service shows that we lose about $2.9 billion to the food imports we make. And also, on average, a farmer loses about 20% to 50% of his produce after harvesting due to post-harvest losses. Ghana as a whole country loses about $1.9 billion every year, as 2023, due to post-harvest losses. And so this was our solution. I'll now take you through the individual parts of our project. Now, the project comes in two folds. We have the dipka and the solar dryer. Please excuse me. Now, this is the dipka. The dipka stands for Distance Plant Care, and this is an automated irrigation system. So the system monitors the moisture level of the soil, and then it pumps water when the soil is dry, and when it is wet, stops pumping. This will help to reduce waste of water in case of overwatering. Also, the farmer is able to monitor these moisture levels through an IoT on his phone. So I'll now hand over to Joseph to take you through the solar dryer.
Thank you once again. My name is Aggrey Joseph, and I'm here to take you through the intelligent solar dryer. There was a time in Ghana where Ashanti Honorable Simon Mensah chanced on a farmer drying his crops on the road. He then asked the farmer to evacuate the place with his cocoa beans, but then he said no. Why? He didn't have anywhere to store his crops. So this setup here is here to solve our post-harvest losses. With a setup like this, we have an LDR that measures light intensity to read light values. We have a DHT, the digital humidity and temperature sensor, to tell the temperature and humidity in our solar dryer. We also have a halogen bulb for an external source of heat. It works on the solar dryer. It works on solar, sorry. It works on the sun. So in the morning, it's outside, and with the help of the solar energy, it dries our crops. In the evening, the LDR, which is the light resistor, helps in measuring the amount of sunlight or light, and then tells our halogen bulb to turn on for the drying process to continue. The reason why our setup is like this is because wood is a very easy substance. Let me see substance. It's common. So then the wood we use here it's less expensive, and as you can see, it's vertical. So then it's storage efficient. Space efficient. We can build about long ones, and in different positions. And okay, yeah, I'll hand over to Elfrida to take.
Now, the solar dryer does not only work on its own, it also comes with its IoT. Please, can you show them the IoT? Where you can check your temperature values and also turn on the bulb. There will be a case where the placement of the dryer doesn't allow you to get proper reading. So just in case maybe you put it somewhere a street lamp is. So even though the sun is gone down, there's still light, then you can turn it on your own using the IoT.
So I'm taking you through the IoT of our project. So as you can see here, we have our temperature readings, and it currently says it's 26.60 degrees Celsius. And for our light, okay, then it's reading values. It's currently reading values. So if we get more light, you realize that the values will increase. That's how it works. And then it's supposed to be this way. If it realizes that there is a lot of sunlight, there is no sunlight, the external source of heat turns on. Or then there's another switch here where you can choose to turn it on or off yourself, no matter where you are. Because it's an IoT, you can be anywhere and still control it how you want.
As a club in Aggrey Memorial, we believe that Ghana has a lot of potential when it comes to our agri sector. And we have identified these problems and have taken the initiative to help solve them. So this is the integrated farming system, which is here to push our agri sector. Thank you very much.
So we'll take any questions from judges, audience, if anyone has any questions for them. So is that your demonstration then? Are you not doing any demonstration to show us how the irrigation system works? Because you still have some time for demonstration, don't they? And then you can talk us through what is happening.
So at the moment, the soil moisture sensor over here is in the soil. So the soil is quite moist. So right now, no water is flowing through the setup. Let me take it off and try to get...
Hello.
It seems like our pump is not working.
So ideally, if the sensor moisture is not there, the sensor will be there.
The moisture sensor. Yes.
It should automatically pump.
Yes. Yes.
But currently, your pump is not working.
Yes.
When did you realize that it was not working?
A few minutes after stop work, when we're doing the setup.
Oh, then so you knew it wasn't going to work when you were demonstrating, oh?
We tried uploading the code again, so I was hoping it would work like right before you came.
Sure. Let me see if anyone has any other questions.
The time is up.
Any questions from the audience? Yes.
So, thank you very much. This is amazing. You used wood, and your thinking is that this will be done in farming communities, right? I know bamboo is usually easier to come by in these communities. did you consider using bamboo or any other material that perhaps they can get access to very easily? Is my first question. And my second question is, if a farmer wants to use this, do they have to come to you to purchase? Or is this something that they can, with your help, perhaps construct on their own? How easy is it for a farmer to perhaps build one or consult you to build one to use?
With your first question, the bamboo side, yes, we could add the bamboo, as you said. We could use the bamboo instead because, as you said, it's easy to procure. Okay, so the second question.
So when it comes to your second question, with the building, I think with proper instructions, someone can build this on his or her own. The problem might come when it comes to the technical aspects, because various crops or various soil will need different levels. So we'd first have to test it and then get our range and then input it into the system. Thank you very much.
And just a follow-up, so what's the cost to make? How much would it cost us to replicate all this? All of it. So cost to make, and how much do you think we should sell it for if someone wanted to purchase it?
Well, at the moment, we can't really give a fixed price. That is due to various factors. The inflation is one of them. Because at the time, some of the items were being procured, the prices were much lower than they are right now. Even the boards that we use, the prices have increased. So unfortunately, we can't give a fixed price.
Thank you so much.
Thank you.
Please give it up for Aggrey Memorial Zion Senior High School. So we'll move on to St. Thomas Aquinas. St. Thomas Aquinas, over to you.
Good afternoon. Good afternoon, everyone. As population increase, demand for basic necessities such as food and shelter also increase. Most arable lands in fast-growing cities have been turned into residential facilities. Do we trade our quest for shelter with our need for healthy and nutritious food? Why? Can we not have both? Our greenhouse aquaponics system seeks to bridge the gap between urbanization and farming. Our system helps people to grow crops and rear fish simultaneously, even in homes with tarred compounds, and it can be done all year round. The system is designed to be built on any available size, no matter how small or large it is. The system makes use of modern technologies to make farming easier and more efficient. By increasing urban farming, we increase or boost the nation's agricultural sector.
So I am Henry here. I'll take you through how the project works. So first of all, the project is in three folds. So you have the greenhouse, the fish tank, and also the seed beds. So we start from the fish tank. So the fish tank here will be the container for water to store the fish. This is an aquaponics system. We have a layer of sand, then a layer of coconut husk, then gravels. So the layer of sand here will produce microbes like amoeba, paramecium, and algae for the fish to feed on. The coconut husks to do the same. And the gravels here is to hold the coconut husks down so it will not be floating in the water. Then we move to the seed beds. So the seed beds here, we have two of them. So let's say here's bed A and here's bed B. So for bed A, we'll be using to grow seeds only. Then bed B will be used to grow seedlings. So we have cotton here to hold the seed firmly to grow into seedlings. And also there's cotton and coconut husks here for anchor for the seedlings as they stay. So when the fishes excrete ammonia, the nitrifying bacteria transform it into nitrogen then into nitrate, into nitrite, then nitrogen, lastly. The soil also provides calcium and potassium for the plants. So this water with the nutrients is pumped to the beds for the plants, then later falls back into the fish tank for like stable water into the fish tank. Same applies to the seedling bed. Then for our greenhouse, it helps attract sunlight for the plants and also keeps the environment humid. The greenhouse also protects the plants from diseases because it's a closed environment.
So I'm Sam Aggrey, and I'll take you through the electrical components. So over here, you could see the display screen, relays, and other sensors over here. So we have the humidity sensor, the water level sensor, and then we have our motors to pump the water into the beds. And then we have our relays that controls those mechanisms so that they are timed very well. Now all these are being controlled by the Arduino board and then this ESP8266 Wi-Fi module. So after reading and controlling the board, the ESP8266 transfers the data onto our IoT cloud-based app so that the user can also view the informations on the app. Thank you.
So now I'll tell you the advantages our model here has over the ones in the market. So first of all, our model here provides a greenhouse and an aquaponics system together. So it provides all year round farming. So when there is time of shortage, like drought and other stuff coming, we still get to grow our crops. Then also, our greenhouse aquaponics system also helps to maximize crop yield.
Our greenhouse aquaponics system meets some few sustainable development goals. It meets the very first sustainable development goal, which is no hunger. No poverty. The system can be constructed, or people can be educated or taught how to construct the system, or also learn how to go into farming using this system. And this helps in reducing the rate at which poverty is in the country. It also meets the second sustainable development goals, which is zero hunger. The availability of this project, whereas growing crops and rearing fishes, provide food for citizens of the country. It also meets the 8th sustainable development goal, which is I think that is. Thank you. My name is Agbanyu Steven Selon.
I am Henry Aram Kwajupo.
So can we move to the demonstration? What can you demonstrate for us today? And if I understand you quite rightly, you have a pond at the bottom that you use to feed your system at the top, the vegetables at the top. So we should be able to see that. Okay. Talk us through what we're seeing.
Over here, the Arduino board and then the ESP32 is controlling the system so that the pumping of the water into the beds is timed at regular intervals. And then the display screen is showing it over here. It's not that bright, but when you get close to it, You can see that it's displaying the temperature, the water level, and then the humidity of the system. Right now, the humidity of the room because it's not covered with the greenhouse. Okay. So then the ESP8266 is taking the information from the board and then uploading it onto our cloud-based app. So it's reading the temperature and then the humidity of the room and then the water level. Since we are now pouring the water inside, it's now dripping to the other side. That's why the water level is very low. But when it gets full, it's going to increase as the water level is also increasing. Yes, please. Thank you.
So I think it's quite evident that your pump, your what's it called, aquarium or your pond is not being able to retain water. What are the challenges that you faced in building this product?
Okay, so after we built the system, we couldn't get time to test it before bringing it, putting it onto it because the time was limited. So I think over there the glue wasn't enough. That's why it's leaking over there. By the time we can pour more glue over there, that's going to make that place very thick so it won't drip. Because the glue is insufficient over there, that's why it's dripping. Yes, please.
That's fine. And again, same question to you. How much did it cost to build, or how much will it cost to make?
Okay. So with this module, it cost us about 3,500 to build this.
Please, you didn't mention currency. 3,500 what?
Ghana cedis.
Ghana cedis, okay.
Yes, please. So the reason being that most of the boards were bought singularly. We bought most of the boards singularly, which incurred transportation costs and other stuffs. That's why it rose to that price. So if you are producing on a much larger scale, meaning we are going to buy most of the components in bulk, reducing our transportation fee and the cost in buying, because if you are buying in bulk, you might get a discount. Yes. So with that, our price will be reduced at market price. But because we build this singularly, that's why the price rose to that level.
So one of the things that would be great to know, and it's okay if you don't know this yet, one of the things that would be great to know would be the amount of food you can get from the system, right? So if it's say vegetables, let's say you are looking at growing lettuce, how much lettuce can you produce all year round? So that if, let's say, I want, because this is bridging the gap between farming and urban living, right? So if I want this in my home, what size would I need to get to be able to produce either tomatoes or lettuce or whatnot, depending on the vegetables I choose to grow, enough to be able to feed, say, my family of 3 or 4 or 5? And that would be very good market information to help you go into the market. Right.
Okay, so for the building, we get to see the size of the area. Then we build it according to your size so I can fit there. So like this one, the cost will vary.
Yes, so, but I want to know the yield.
The
yield.
Okay, so per every 2 months, we get to produce at least 10 lettuce from the seedling side. That's the shallow rooted crops. Then the C2, we can produce at least 20 seedlings to go from seedlings to seed.
For this size?
Yes. Are you sure? Yes, please. Like 2 rows.
How many pumps will you typically have in maybe, yeah? And how many pumps? And then how does that affect the fishes in the pond?
How many pumps?
Oh, okay. So over here, you have 2 pumps actually. So when they are pumping the water, they pump out the waste of the fishes. That's producing contaminants for them, making the water toxic to them, to the plants, to serve as nutrients for the plants to grow. So when it takes the dirty water over here containing the nutrient, that's the waste, and it comes here. The coconut husk, and then the cottons, filter the water, making it clean again for the fish to be able to live inside. Yes, please.
Yeah, guy. My question is, do you pump the water directly from the pond to the vegetable bed?
Yes, please.
Why?
This is because the pump is submersible, and this is the aquarium where the water will be. So the water is being pumped from the aquarium to the bed. And since the ammonia is in the aquarium where the fishes live, the plants get to use their nutrients for growth.
No.
No, please.
No.
It's pumping at a low pressure.
But you know the ammonia will kill your plants, right?
Is that?
The ammonia will kill your plants.
That's why there's sand and coconut husk here to produce nitrifying bacteria in natural phenomena. So once there's coconut husk, sand, and ammonia around, nitrifying bacteria get to grow, then do their job for the plants to get the nitrogen to use.
Please give it up for St. Thomas Aquinas. I think St. Thomas Aquinas have been here for the past 2 challenges. So this is their 3rd time at this challenge. So give it up for them. And then we move over to somebody that it's their first time joining us at the challenge, Bosum STEM Girls Senior High School, our only girls' school represented here. Yes, and they get a bonus mark because they used 2 contestants to build their product throughout the whole 2-day challenge. Over to you.
Good day, everyone. My name is Kujo Rashida Abinatri.
Patricia Mwakwa Tia Priscilla.
We are here to represent on the theme, Exploiting Agri-Tech Solutions to Boost Ghana's Agricultural Economy. The name of our project is the Vertical Hydroponic System. Welcome to Smart Hydroponic System, a revolutionary approach to sustainable agriculture. Our mission is to harness the power of vertical hydroponics to transform the way we grow food, making it more efficient, productive, and environmental friendly. In a world where population growth, scarcity of water, and climate change are increasingly pressing concerns, innovative solutions are needed. Albert Einstein once said, technology should serve humanity and not the other way around. This is why this vertical hydroponic system of ours offers promising answers. Now, one may ask, what brought about all this project? Why this at the first place? Challenges in maintaining field and managing of plants during drought, soil degradation, scarcity of land for farming due to urbanization, which is increasing global food insecurity concerns. Based on the above background, we thought it is necessary to implement this vertical hydroponic system.
So, to curb this challenge, we, the students and our coaches, visited hydroponic and crop farming sites in the Diakun. We observed that there is food insecurity leading to inaccessibility of good food to the people of the community. In our survey, we conducted a series of interviews with some farmers, and it came out that very few of the farmers practice the modern way of farming. So to boost our country's agricultural system, we, the students of Bosum STEM High School, have come up with a fascinating project called the Vertical Hydroponic System of Farming. This is a system of farming whereby plants are grown in a controlled environment. They are nourished by a nutrient-rich solution rather than soil. This means that the plants are grown without the use of soil. Water, oxygen, and nutrients are abundant, and also light, humidity, and temperature are controlled in this system of farming. One exciting fact about this system of farming is that water is recirculated and reused, minimizing waste. Over here, we have our temperature and humidity sensor, which senses the temperature and humidity in our environment. But I think we have a problem with the display board because I think it wasn't really working really well. Yeah. Okay. The plants are grown in layers, as you can see, one on top of each other. Yeah.
Okay, so we have here the solar tracking system. Solar tracker, a system that positions an object at an angle relative to the sun. This solar tracking system is designed in such a way that it follows the sun, which results in 10 to 25% more output efficiency. We have 4 types of solar tracking system. We have the single-axis solar tracking system, the dual-axis solar tracking system, the polar-axis solar tracking system, and finally, the azimuth solar tracking system. Here in our case of the project, we are using the single-axis solar tracking system. How the solar tracking system works. When the photoresistance tracks or sees that the sun or light is at this side of this side or this part, it automatically turns to this side. Vice versa, when it's also here, it turns to this side. It tracks the sun and makes sure it catches the sun rays. At the same time, it also recharges itself. It is observed that tracking systems are more efficient than the fixed system with similar capacities. Normally, tracking system along with the solar panels are fixed on rooftops of small industries and residents.
We will move to our aquaculture. We will move to our aquaculture farm over here. In here, we were supposed to bring some fishes, but due to traveling inconveniences, they are all dead. So here, the fishes are treated, making the water nutritious the water being used to plant these crops, making them very nutritious, needing no inorganic fertilizers. We also have our AFS system, which is the automatic feeding system. This automatic feeding system is being controlled by a servo motor, whereby the servo motor will turn in a specific time that will give the animals food in a specific amount, making them get food to get more health. And the water here will be being changed in 3 days' time so that it doesn't get more nutrients for the crops, because over nutrients spoils the crops over here. I would also like to tell you more about the importance that we have in our vertical hydroponic system. It saves space, it is recirculated, so making it save a lot of water. It is less expensive, it is eco-friendly, it's flexible. We can make any changes if there is time.
We would like to recommend this project of ours to everyone out there, especially those in the urban areas where land is scarce. This project of ours does not take up space. You do not need a large area to produce this. You can practice it at the backyard or in front of your house. Also, water is not wasted. Everything here is in a circular form. That is, water is pumped from the agriculture to vertically to the crops on top and back to the agriculture again, which ensures that water is not misused. Last but not the least, it is cost efficient. This is not expensive. It can be purchased by anyone and everywhere. It's not expensive. And also, everything here is automated. You do not need labor force to do it. We hope and it's our prayers that in the next 6 months, we will be able to expand this commercially to produce more lettuce and get like 5,000 from it, since it's very productive. Dear judges, ladies and gentlemen, to summarize everything, smart vertical hydroponics system represents the future of agriculture, offering efficient, sustainable, and sociable to farming challenges. By integrating the IoT, AI innovative techniques, this system can able to transform how food is grown, Thank you. Sure. Water pump. It's not working.
1 minute more. Have you tried it today?
Yes, we tried it. It was working perfectly. Everything here was working by now. That was the first thing we checked. It was working.
Did you take a picture or a video of it when you tried it?
No, I don't know if the cameramen really have a shot of it because they were all around. That was the first thing we tested and it was working.
All right.
It's so unfortunate.
So, any questions? Let me open up for questions whilst you get that sorted.
So you mentioned that you did some research before deciding on what project to undertake. What crops are in the community you searched? So there's a solution for that community, right? So what crops are typically planted in the community? And will your system work for those crops in the community?
Okay, so talking of the crops the community grows is mainly cereal and vegetable fruits, maize, cassava, lettuce, carrots, and tomatoes. And yes, it worked because I first think the first one we tried using maize on it, yes, and it was working. We later turned it to lettuce because if we continue going with this, it might overpower it, and our system we have here is a small one. So yes, we tried it.
How is this system different from aquaponic?
Please come again.
How is your system different from aquaponic system?
There's a slight difference because ours is automated. You don't have to use manpower. Everything here is automated. The soil humidity sensor here, it checks everything. And also the fishes we have here, it's naturally excretes because you can't grow crops with only water without nutrients. So we specially added our fish to it to make it get nutrients so that it can make our plants healthy and grow well.
Yeah. So I'm getting confused because aquaponic is when you have the water circulating between your pond and then your vegetable bed. Here is the case, you have fish, which is your pond, which represents your pond. So there's a circulation from the poops, excuse me to say, of the fish to your bed. So this defeats the purpose of this being a hydroponic system. So I need clarity on that. And then secondly, what substrate are you using for your vegetables? Your vegetables, what's the substrate? What did you plant them in?
What did we?
You don't use soil.
Okay, to make the lettuce firm, we added foam. There is foam in, yes, to hold it. You can use other things like coconut fiber and the rest. And also, just as you said, the aquaponic and ours, there's a slight difference. Ours is in a vertical form, and also we added the fishes into it because even though water is a vital nutrient, it doesn't contain everything that the plants need. So the excretion from the fishes will help the plants to grow well.
So I think what the judges are basically saying is that it sounds like you started with a hydroponic system and you thought, you know what, let's add another level of complexity. Let's make it aquaponics as well. So that is where the confusion is coming from. Whether are you hydroponic or aquaponic or both?
Please, the reason why we added the water here is to provide the crops with some nutrients because we can't
With the fishes?
Yes, the water has been served as the nutrients for the plants because...
So it's both a combination of vertical farming and harvesting byproduct of...
Yes. It's hydroponic because here we use the cotton to make the stand, but because we need some nutrients for the crops, that's why we use the water as the medium of the fertilizer for these crops over here. Thank you.
Yeah. All right. Thank you so much. Give them a round of applause. So over to Fijai Senior High School. Fijai, I think you've been here before, haven't you? Or is this your first? Oh, welcome to Sci-Tech Challenge. Please give it up for Fijai Senior High School. So Fijai, over to you.
Good afternoon, welcome. I'm Amia Jabedu, and today I'm here with
Theophilus Mason.
Frederick Kishen.
On November 9th, 2024, an article on myjoyonline.com made us know that 68% of soils in some districts in Ashanti region are acidic. It has affected farmers really bad. Also, improper fertilizer application and culture practices and farmers' ignorance about soil and crops has led to reduced yields. This has really affected the agriculture sector and also gone a long way to affect the economy of Ghana, since agriculture sector is one of the backbones of Ghana's economy. Compounding this, farmers lack access to advanced technologies that has led to inefficient practices. So one may ask, how can we help the agriculture sector that contributes about 21% to our GDP? Now, that's where Auxilium comes in. Auxilium is an agri-tech developed by a passionate Fijai SHTS team that will help give the farmer information about the soil. Thus, give real-time information about the soil nutrients, soil moisture, soil acidity, temperature, and humidity. In addition, Auxilium would help create job opportunities, thereby help in achieving SDG Goal 8. Also, Auxilium would not only help. In addition, Auxilium would not only help boost the economy, but also help boost the agriculture sector, thereby helping achieving the SDG Goal 2. I would like to give it to my colleague to continue.
Okay, so I'll continue with how our setup is. So we have the soil, as you can all see, and we also have the device. So in our device, we have the input section, the processing section, and the output section. At the input section, we have our sensors. We have the MPK sensor, the soil moisture sensor, the DHT11, which is the digital humidity and temperature sensor, and the pH sensor. So, and at our processing section, we have the board, the microcontroller, which is Arduino, sorry. And at the output section, we have the LCD screen, as you can all see. So what our device is going to be doing is this. We will get the basic parameters from the soil. And the sensors will send the data they've obtained from the soil onto the Arduino board. Then, as the processing device it is, it's going to convert it into information that can be displayed on the screen for everyone to view. And another nice feature we've added to our presentation is the work of the on-field guides, who are going to be experts, agricultural experts with technical know-how. They are going to be looking at or observing the various parameters, or they'll be looking at the screen to look at whatever is happening in the soil and relay it to the farmers, because some farmers may not be able to read it directly due to their situation. It's not your fault. But we need to get them to know what's actually happening to the soil, and that's where the on-field guides come in. So I'll give it to my friend for the demonstration.
Okay, thank you. So for the demonstration, we'll first connect. So now we've connected our system to our computer where we have the codes on it. So we'll first insert all the sensors into the soil to read the various parameters. So you can view from the LED screen to be displaying the various parameters present in this soil we are having. So yes, please. The LCD is working. Yes, we also have to display the nitrogen, potassium, and phosphorus content, but because of the screen, we couldn't display it here, but we have displayed it on our web, which I'll be showing to you right now. So our open source web is displaying the nitrogen, the potassium, and the pH level also present in the soil.
So this one says 5.65, this one says 5.
Yes, so there's a bit normally so.
So which one is the correct one?
Actually, this one is the correct one.
So how are there anomalies here?
Because it takes time. So it has to, so the readings here would delay. So maybe the time it is displaying 5 years. It's on the web, so it has to go through a certain process to get it. Yes, please. So with all this information, the farmer will not be left guessing about how to apply the fertilizers on the farm, because he knows that the pH is at this level. So if he has to lime it or to determine the type of crop he can grow, that the soil here can support. So we would like to recommend it to the Ministry of Agriculture to look into it further, so that the farmers will get adequate information about the soil, so that they can put in place the necessary cultural practices to increase yield in the country. Thank you.
Okay, so you said you're going to provide real-time data. How are you going to go about that? And then the other bit where you are using on-field officers. Are there other ways to actually get that done without getting people to go on the field? Because you're already capturing this somewhere, right?
Yeah. Oh, about the on-field guides. We're saying that if we could get the on-field guide somewhere, maybe the farm we are putting into consideration is far away from urban centers. So I am saying that the on-field guide will be at that, will be where he stays. Then he will be communicating to that farmer in the remote area. That's what I'm saying.
But your device is getting the data and is going somewhere. So if this was sitting in the cloud somewhere, why do you need someone to go onto the field? And then if you could push the information via SMS or email to the farmer, why would you then?
The reason why we didn't do this directly is because we presume that not everyone is, should I say, privileged to be able to actually read from the SMS. So most of us, as I was saying, not everyone is privileged to be able to read from SMS. So the best thing is we try and contact that person, since the person will best be able to communicate in language. And we will also give advice in addition.
So you provide advisory services, and you would call them and have a voice conversation.
Yes.
So then you don't need an on-field officer, do you?
Oh, I mean, we have created it, but we will need the on-field guide. He will be doing the...
I'm just trying to get you to reduce your cost.
So how would this work? I have a 1 acre farm. How would this work on the farm?
Oh, okay. According to our research, this device can measure a very wide range. It said 10 to 20 acres, according to our research.
Okay, so tell me how. Because I see you dip a number of pieces into a little container,
yes,
right? And I have 1 acre in front of me. How will I measure?
Okay, that will depend on the plant you are cultivating. If we are planting, if you are cultivating the same plant, then we may assume that the factors, each plant may absorb the nutrients and may cause changes in the soil at the same rate. But
maybe one other person can help you answer this question. I have 1 acre in front of me. You've given me a dipstick and a few other pieces. How do I check for the entire piece of land?
So
So let me just add to it that on this 1 acre farm, we have different beds with different crops, with different conditions. Where and how do I apply your one set of dipsticks and sensors to make sure that I have an accurate representation across the whole acre of land?
Okay, so since we are not cultivating just one crop, and as you said, the conditions are not the same, this device here looks portable, so you can use it on the first bed. Then then with the help of the on-field guy, you get to know what to do. Then you move it again to the next bed. Then you check, then record it. Thank you.
Thank you so much. Please give it up to Fijai. No, those are already working funny. So Ghana National is one of those schools that have been here, similar to St. Thomas Aquinas. They've been here for every year, and I think last year they came quite close. So Ghana National, what do you have for us this year?
So we are the Energy Efficient Club of Ghana National College, and we are here to introduce you all to the 21st century system of farming. So this project is represented by me, David Tete.
Chris Kwachisiao.
And Kelvin Yuring.
Okay, so agriculture continues to be the backbone of the Ghanaian economy, providing about 20% on average to the nation's GDP. But it's very clear that the future of agriculture is at risk and is very concerning. So we have many problems affecting agriculture, and some of these is rural-urban migration. So plenty people are moving from places, and people are continually building houses. And with all these problems, the space for farming is getting limited. So we decided to build a system that will solve that problem. Also, when we look at the side of illegal farming, people are mining illegally, and also the use of toxic substances for the mining, such as cyanide, sulfuric acid, and other things they use to separate the minerals from the ore. Also, they also bring hazardous substances into the soil, and it affects agriculture. So looking at all these problems, we decided to build a system that will address all those problems. And aside addressing them, it will help boost the nation's agricultural industry by providing income. This system does not only boost the nation's agricultural industry, but it also addresses the SDG goal 2 and 3. So what actually inspired our project was a research conducted by one of our students. And this research, we found out that many of the diseases that affect people are because of lack of vegetables and fruits. So we decided to build a system that will help every individual to be able to grow vegetables and fruits even in their households. And this system is a vertical farming system. One may ask, what is a vertical farming system? So a vertical farming system is the practice of growing crops in vertically stacked layers, rather than the traditional horizontal system of farming. So with this system of farming, the farmer is able to grow much more crops on a small piece of land. So this system of farming has many advantages. And some of these are utilization of less space and water. And also this system of farming helps to provide employment. So you can start your own farming in your house, even if you are not a farmer, with this system. Also, this system of farming is easy to transport. So you can have your farm with you, and when you are moving out, you can carry your farm along. This system of farming has many advantages. And some of this is also longevity. So we use pipes. Why did we use pipes? We realized that from our research, pipes can last a year from 75 to 150. So you can keep your system for a very long time. I'll pass on to the one who did the electricals to continue.
Okay, thank you very much. Let me explain the whole project. So, since solar energy is one of the renewable sources of energy we have in Africa here, my team and I decided to utilize the abundant solar energy in developing a unique project. So in doing this, we designed a solar tracking system to harvest the maximum amount of energy from the sun. That is, at any given point in time, we are going to have an average of 10 to 12 volts, which is very good for this system and even a household. Yes. So the solar charge controller is then the solar panel is connected to the solar charge controller, which is then used to charge our battery in this box. The battery is then used in powering the automated irrigation system. That is, automation is going to occur automatically. So there is no need for you to come and be standing around operating things. Yes. And this system is designed in a way that I suppose it seeks to fit any kind of person. That is a layman and an educated person. So we have 3 modes of operation for this device. That is the switch mode. That is if you don't want to be using your mobile phone for any kind of adventures. So we have the switch system to do that for you. We have the mobile phone application. You can turn on your water pump with your mobile phone. You can turn on your lighting system for your mobile phone. And according to our research, low temperatures slows down metabolic and enzymatic processes, which reduces the rate of growth in crops. Hence, we included red and blue lights to generate heat for crops. It also regulates the opening and closing of the stomata in the leaves of the crops. Yes. So in doing this, it increases the rate of growth in crops, and it produces a more hygienic farm produce. Yes. So this is basically our project. And the water used for irrigation is drained through these pipes back into our reservoir container. But then, since the water from the soil will be dirty, we included a filtrate to filter out debris and dirt from entering back into our container. Yes, that's basically our project. Thank you very much.
Okay, so to conclude, what we mean by all we've said is that with this system, we are trying to do more with less. And what do I mean by more with less? So I mean, first, we are using less fertilizer, less soil, and less water to generate more crops. And that's what I mean by more with less. So generally, what I'm trying to say here is vertical farming is just farming in space, farming with less space, and farming in the air, rather than using more land. And that's all our system is about. We'll now try to demonstrate to you. Okay.
So, as you can see, we have a sample of water here, which are soil moisture sensors in it. So, as soon as you take it out, the pump turns on and the irrigation starts to come down. Sorry. That's the irrigation you just noticed. So, if our moisture detector doesn't detect water, the pump turns on and the water is pumped from our reservoir chamber onto the farm for irrigation. That's basically the project. And to make this our project unique, we included an inverter. People requested for inverters, but then they were very expensive. But in this case, we built one. We included an inverter into our project. So we have a plug here. When it turns on, it shows your mobile phone is charging. It charge. So yes, as you can see, the light is on. And to prove that there's no connection to this device, you can come and have a look around to see if there's any connection. To clarify that there's no power running to this device. There's no power. The power is generated directly from our box.
There's no DC battery?
No. There's a battery here to store the current. So you can bring a light bulb, 220 light bulb to test if it's actually working. And it's charging a mobile phone here, as you can see. The mobile phone is charging. So it's an inbuilt inverter. Yes. So in case you have this in your house, you can just plug in your AC up plug, connect it to your home, and it serves as a mini storage for power, and also it can be used to power your homes and other things. Thank you very much. The solar panel, okay. Check CD come.
make sure it acquires the maximum amount of voltage to be stored in the battery, and then when the project needs it, it makes sure it outputs the maximum amount of voltage for the whole project to work. So basically, that's our project. Thank you very much. And we cannot talk about food security without storage. So hence, we designed a mini refrigerator, which consists of a peltier. So the peltier, it has two parts, a cooling side and a heating part. So we included a CPU fan to dissipate the heat at the heating part. And we also added a cooling fan to also eliminate the heat into the silver lining of the refrigerator. So basically that's how and it's also solar powered. So the power stored in the battery is then laid to feed the refrigerator. So your harvested food crops can be stored here for a longer period of time. Yes. Thank you very much.
Yes. Okay, thank you so much. So at the moment, your irrigation system is just on the first floor?
No.
One, two, so. But your demonstration, we only saw on one floor.
Yes, so the pipe is connected from here, and it's laid up here, through here, and back here. So it's...
Or at the moment, your demonstration is just showing its feasibility at this level? Okay, we started.
Yes.
So if the force comes first on here, then
yes.
So
when the water gets up here, the pressure reduces and the water gets into the pipe to irrigate.
But by that time, the bottom one will be flooded, or?
No, that's why we have a drainage system down here.
Okay.
So the pipe will never be flooded.
Okay.
Yes.
So there's a draining, there's a draining system.
There's a drainage here. Yes, there's an outlet for that. Yes, it goes back into our reservoir chamber.
All right. Any questions? All right. Please give it up. Ghana National College. Please mop up.
Thank you very much.
So we're coming to Obuasi Senior Technical. Obuasi have, like National and like Aquinas, Obuasi have been here for the past 2 competitions and the third one. And each of the 2 competitions they won. So they are the defending champions. So I think they have a lot to live up to because their predecessors have set a certain level. So Obuasi, over to you.
Thank you so much. Dear judges, ladies and gentlemen, good afternoon. I am Esther Odum, and my colleagues are Mate Abednego and Abubakar Ikram. We are students from Obuasi Senior High Technical School, and in this year's Sci-Tech Innovation Challenge of exploiting agri-tech solution to develop agricultural solutions to boost Ghana's agricultural economy. We present to you the Osikeni Farm Solution. Farmers in Ghana and across Africa complain about certain challenges they face in the agricultural processes. These challenges and threats I'm referring to, some are the capital to accommodate laborers to weed their farm, and also the risks of farmers being exposed to the life-threatening effects of chemicals used on their farmland. The Osikeni Farm Solution is a multi-task device that can weed, spray chemicals on crop, stir chemicals automatically using a magnetic stirrer. It can also detect the weather condition of the farm, and it is powered by a solar panel. It can be controlled manually and remotely. Dear judges, the Osikeni Farm Solution is a solution that fosters new ideas, and it is cost-effective. It can be operated easily. Our objective of developing this device is to design a multifunctional farm solution that can weed, spray chemicals on crops, stir chemicals automatically using a magnetic stirrer. This magnetic stirrer helps prevent the unhygienic way of farmers using their hands and sticks to stir chemicals. It also have a weather station that detects the weather condition of the farmland and also outlines the information on the mobile phone of the farmer. We would like to give a demonstration of how the Sunyani farm solution works. Dear judges, as they're about to begin the demonstration, they'll be moving around, so we would like to give a little space so that the machine can move around. As I said earlier, it can be controlled manually and remotely. So they're about to begin with the manual control of the device. Dear judges, I made mention of a magnetic stirrer. I would like to come and have a look of how the magnetic stirrer works. So this, instead of the farmer to use the stick or the hands to stir the chemicals, the magnetic stirrer will be stirring the chemicals evenly. And this is a very hygienic way of stirring chemicals in the farm. Mostly, the magnetic stirrer is mostly used in science laboratory, but here, we are using it in our farm solution to help farmers easily stir their chemicals at their farm. Okay. So we use a GV paint to avoid. So I said earlier that our device can be used in spraying chemicals on crops. So this is the pump, and it's controlled by this button. So the farmer would no longer have to carry the spraying machine at his back. This will help the farmer easily spray chemicals evenly on their crops, other than the other machine. It does not spray the chemicals evenly on the crops. So this is how the pumps works. Thank you so much. Our device has been designed in a way that it can move in all directions. So as the farmer sits on the device, he can comfortably be applying chemicals on the farmland. Behind our device is a slasher. The Sunyani farm solution is equipped with different kind of hose, but for demonstration's sake, we didn't use metal, we rather decided to use the slasher. So if it were to be a hole attached to it, it would work the same way as it's now doing. If we're to be at the farm right now, it would have been weeding the farmland. This is an easy way of weeding the farm. So as the machine moves, the farmer will be moving the farmland. Please, let's appreciate. So that's the slasher. If we're not in need, it can be rolled up by the puller here. When the farmer is about to use, then it will be rolled down. Dear judges, we would now like to have how the remotes also can be used to control the Sunyani farm solution. Please, we are very sorry. We use DV paint, so in case of any stain, there won't be. So the remote too can equally be used to control the device as manual. Thank you. It can also be used to control the slasher, as I said earlier, both manually and remotely. So how you would have operated it manually, the same way you can use the remote to control the device. This way, the farmer can be at any safer location if he doesn't want to get infected by it or gets the effects of the chemical use. He can use the remote to control the device. As I said, our device have a weather station attached to it. The weather station can be removed and the farmer can mount it anywhere in the farmland. But for demonstration, we attach it to our device. But if the farmer wants it to place it at any location in the farmland, he can remove it or detach it from the device and place it at the preferred location. The weather station is made up of different sensors. Sensors that can detect whether there are intruders in the farm and also detect the temperature of the farmland. It can also detect whether there is smoke in the farm. All this information and many more will be displayed on the mobile of the phone, on the mobile of the farmer. Thank you. Dear judges, this is the information the weather station displays. Here, it is displaying the temperature of this room, the humidity, the light intensity, smoke, and also, we have a moisture sensor in our device. It can detect if it's detached from the farm. The farmer can place the moisture sensor in the soil so that if the soil is dry, the machine will automatically irrigate the farmland. And also, if the soil is moist, it will also show it on the mobile app of the farmer to know how to go about his actions in the farmland. So, if you like to. Thank you. And also, dear judges, why invest in our device? Cost analysis. In the next 2 years, we will be able to produce 8 units per month, making a total of 96 units by the end of the year. 40 people will be employed. 40 people will be employed. Our device will be sold at a selling price of 4,500 Ghana cedis in Ghana, including tax, and $313.30 US outside Ghana, excluding tax. We will be able to make a profit of 150,000 Ghana cedis, and this profit will be used to expand the business. Dear judges, when the business is expanded, in the next 5 years, we will be able to produce 10 units per month, making a total of 120 units per year. 100 people will be employed, and we will be selling the device at a price of 5,000 Ghana cedis in Ghana, including tax, and $400 US outside Ghana, excluding tax. A profit of 500,000 Ghana cedis will be made. A profit of 500,000 Ghana cedis will be made. Food sovereignty. Dear judges, we will be able to, by the next 5 years, more of the Sunyani farm solution will be made and made affordable for farmers to be able to use on their farm to produce more food and make food abundant in this country. This will help boost the agricultural economy of Ghana. Training. Skill training will be given to the youth to equip them with the necessary technical know-how to be able to render services, maintenance, and installation of the device.
Thank you so much.
Thank
Your
you.
time is up.
Thank you.
Thank you so
This is the
much.
Sunyani farm solution.
So let me take questions from the audience. Any questions from the audience? Any questions from the audience?
So I'm just curious, what's motivated all of this? Where's your motivation coming from?
Okay. Please, thank you for the question. We realize that in Ghana, There are numerous complaints about weeding of farmland and also application of chemicals in their crops and also the spraying of it. And also the transportation of the crops from the farmland to their homes. They sometimes say the transportation fee is very expensive. So we decided to innovate all the solutions to this problem in one device. That's the Sunyani farm solution, which can weed the farmland, spray chemicals, also transfer the crops from the farmland to the various homes at their comfort zone. And also, most farmers use either sticks or hands to stir chemicals in their farmland, and it's very unhygienic way.
That one we got in your presentation. So we're not asking what you said in your presentation.
Sorry.
I think what she's trying to find out is that, did you do this for this challenge, or is this a genuine solution for the future?
It's a genuine solution for the future.
So had this competition not come, you still would have done it?
Yes, please.
All right, thank you so much. Give it up for Obuasi.
Thank you, too.
We move on to Sunyani Senior High School. Yes. Sunyani is also, this is their first time at the Sci-Tech Challenge. Please give it up for Sunyani. So Sunyani, over to you, and welcome to Sci-Tech Challenge.
Thank you very much, madam.
And can we please be quiet as we hear other people's presentations? I may have to deduct marks if the school is making too much noise to disrupt other people's presentations.
Please, good afternoon, ladies and gentlemen. Please, my name is Reggie Bamford Domejere, and here are my colleagues.
Adebayo Betoda Yonsum.
And I'm Osei Kumimano. Okay, today we are very happy to be here, even though this is our first time, so we are very happy. But as rightly said by the MC yesterday, pests are most dangerous insects that are causing much trouble to the agri sector in this country that many of us don't even know of. If you can make reference to our slide, you can see that we had some pictures whereby the pests have destroyed a lot of crops. And with this, imagine being an investor and you've invested in the best way of, producing your crops or farming, and you forget the effect of the insects that might attack your crops, and you invest in those expensive procedures. And out of the blue, one day you realize that your entire farm is being affected by insects such as the white flies, the four-army worms, and other insects. What will you do as a good farmer? I know that definitely you are thinking of spraying it, right? But have you considered the health risk, the quality of your produce, and then the ecological factors? I guess not. This is why the Presec STEM Club, we sat down, even though we had a live, experience whereby the school, farmed, they planted tomatoes and then maize, and then we realized, even though the land was totally fertile, and then we realized that it was affected by these insects. So we sat down and we thought, we came up with a lot of ideas, and we planned this machine as you see here, called MISPAD. So I'd like to hang out to my colleague to go on further for you.
Thank you very much, Reggie. We have here the multi-purpose solar-powered agri-tech device, MISPAD for short. And as my colleague said earlier, we are targeting 6 key pests. That's the white flies, the locust, the fall armyworm, the cocoa pod borer, the stable fly, and the oriental fruit fly. To talk about the white fly, based on our research, we found out that the white flies are able to transmit plant viruses such as the tomato yellow leaf curl and the CMD, that's the cassava mosaic diseases. So, let's come to MISPAD. We have here a screen filter that can be used to separate larger beneficiary insects, such as the butterflies and the bees, from entering our system. Some of the objectives behind MISPAD is that First of all, we want to overcome the challenges that the already existing methods in eliminating these pests are facing. Provide a clean energy that can be used for irrigation. Protect the life of farmers. And therefore, we are targeting to eliminate 6,000 pests per day. Please turn the switch on for me. Okay. As you can see, we have the blue LED lights, which works on the principle of positive phototaxis. So the blue LED light, based on the targeted insects that we want, we set the light color to 8. Okay, so we're able to find out that the yellow light, which works with positive diurnal phototaxis, works on well with the white fly. And the blue LED light also works very much on with the cocoa moths, the oriental fruit fly, and the stable fly. So based on the targeted insect that we want on your farmland, then you set the light color to it. We have an electrocution grid here, which when MISPAT is operating under the illumination mode, we set the electrocution grid so that when the pest comes into contact with the device, it electrocutes it. Using, as you can see, yes, we're having a step-up transformer that's able to take the 5 volts from the battery and step it up to 400 volts. But during our testing this morning, it failed out. So we are picking the 12 volt directly from our battery for demonstration. We have a suction fan here, which forcefully pulls the insects when they get attracted to the LED light. And working under the collection mode, we have a trap net. When this trap net is inserted, we remove the electrocution grid and the windmill here. So when this one is inserted here and the grids are removed, the insects that are trapped in these nets can be used for entomological studies in the universities. And also they can be used as additive to poultry feeds when we are working under the collection mode. To add up to 8 multipurpose nature, this strong fan here can be used in our warehouses in replace of the extractor fans to control humidity in the warehouses. Also, the windmill here can be, we wanted a 12 volts dynamo to be used, a 12 volts dynamo in place of this one. This one uses 5 volts dynamo. So the 12 volts dynamo, if we had it in place of this one, we could have used this for our irrigation system. And also to our battery here uses 12 volts to be charged. So let's say during the night when the fan is operating, we might not get power supply and the solar panel, there will be no sunlight. So the 12 volts dynamo from the windmill can be used to recharge the battery as the wind continues to blow. But for demonstration, we are using the LED bulbs to demonstrate that how it will work for us. Yes, thank you very much.
So, before we came up with this magnificent device you're seeing here, we first of all thought of ideas, some agricultural problems in reference to this year's STEM festival theme, that is exploiting agri-tech solutions to boost Ghana's economic and agricultural industry. So we first of all thought of the idea, some of the problems, and realized that in Ghana, insect pests pose a great threat to the agricultural sector. Then we drafted out several designs to be practically oriented. We chose the best design. Then we wrote our the materials we'll be needing. Then we were provided with the materials. Then we started construction. So during construction, we faced some few problems. Our step-up transformer broke down. We couldn't, we weren't provided with a fan, a proper fan for the windmill, and also we couldn't afford, we were not provided with the 12-volt dynamo. That made it limited. So we are, as my brother said here, we are targeting 6 key insects. So that is the oriental fruit fly, locust, the 4 armyworm, the stable fly, the white fly, and the white fly. So with this, we use some principles. That is, principle of positive phototaxis. That is, insects have photoreceptors in their eyes that allow them to see certain colors of light. So in our diagram, you see that the stable fly the sable fly, the locust, and then the 4 armyworms, they are attracted to blue lights. So with this, we'll make sure that there are blue lights that are placed in our device in order to attract them. The white fly, which is our target for now, is attracted to the yellow light. So when we are targeting the white fly, we make sure that the lights are white. The white fly, we make sure that the light is yellow. So we also use some chemotaxis, principle of chemotaxis, which is some insects are attracted to certain conditions of chemicals. That is CO2 attractions for the stable fly, and also they are attracted to pheromones, synthetic pheromones, and also smell of certain fruits. For example, the cocoa pod borer, it is attracted to the smell of the cocoa seeds. So when this is kept around our device, it will mimic a cocoa tree, drawing the insects closer to our device. We also use the principle of hygrotaxis, which is they are attracted to certain humidity. For the white flies, attracted to 60 to 80% humidity. So when the 60 to 80% humidity is created around this device, the white fly will want to come around the device. We also use the principle of thermotaxis, that is temperature. These insects, insects of agriculture are attracted to temperatures. So with the white fly as an example again, it is attracted to 20 to 30 degrees temperature. So with this around our device, they want to come near our device.
Okay. So with this, we thought of that. Let's talk much into business right now. Okay, with this, the cost of this is 12,000 to 20,000 if you are to implement everything that we need as large as we want for it to work effectively for everyone. The cost is 12,000 to 20,000, and the profit is 14,000 to 24,000 with a percentage of 20% and all that. So with this device, I urge everybody to, invest into it for us to produce more, to reduce the number of pests in our environment or farms that are causing much trouble to us.
So with this device, when this device becomes a product, it escapes the prototype development cycle. We'll make sure that after every unit sold, we'll donate one to a less endowed community. There are certain communities that can't afford this because of the price. So we'll make sure that we donate one to reduce the number of agricultural pests in that area. You will also be wondering that the price is very much, it's a huge sum of money. But let's just consider buying chemicals every month and paying for hospital bills out of eating these foods that we spray. We see that we are spending even more than the amount you're going to spend on this. That is why we call on the MOFA, Ministry of Food and Education, Agriculture. We call on each and every farmer that is struggling with one type of agricultural pest or another, and each and every person who wants to eat quality foods, not to go to the market, buy tomatoes, and realize that inside is green, outside is red, because of spray, because they wanted to kill some insects on it. Thank you.
Thank you so much. Thank you so much, Sunyani. Let's take some few questions. So I guess my first question for you is that to be able to successfully implement your device, does it need to be in an enclosed space? Does it need to be in an enclosed space?
So thank you for the question. The device doesn't have to be in an enclosed space. It has to be seen. That is why there are lights. So the light has to be seen. So with this device, it covers a standard football pitch. So it needs to be in an open space.
How is it going to stand the test of time in terms of the weather? How will it survive under the weather, under the rudiments of the weather?
Since this is a prototype, if we get all the necessary materials, we intend, instead of the wood, we give it a metal cage and maybe a canopy so that when it rains, the water won't attack the device straight for it.
And because of the budget was limited, so they don't want to exceed our budget. So we decided to use the wood frame.
Can your lights be alternated? your light sources, can they be alternated? So for instance, if I'm targeting a particular insect that's drawn to yellow, can I change all of them to yellow? If so, can you demonstrate for us to see?
So with these bulbs that we have here, we requested for 12-volt bulbs and the ones that change colors, but we're not provided with it. So the ones we got were only one colored bulbs. That is why you see this. Yes, or depending on the insect.
Okay, that's what I want to see. Thank you.
You're welcome.
So, I guess it's solar powered, right? But I'm not seeing the panel connected to it. I'm wondering.
So please, the panel is here. And because there's no sunlight here, connecting it, we decided to give it a battery source. So that is where the solar panel will be connected with these two wires. So it will be connected to the solar panel from here. But because there is no sun here to power it up, we decided to put the solar panel by it.
And also, because during our procedure, our battery ran totally low, so we needed to charge it urgently just to demonstrate. That is why we placed the solar panel aside and then we are charging it.
But you requested for the panel,
yes.
Right? So we're hoping that you could demonstrate with that for us to really see. Because that's why I came around to look around. I realized that it was not solar powered, but from another source. So we need that clarification.
So as you can see, since we charged it a little bit, even though we've taken it out of the electrical source, but still it's working on its own. That tells you that if we connect it to the solar panel, still it will continue the charging and it will work as we want.
All right. Thank you so much. Please give it up. Please give it up for Sunyani Senior High School. 3 more to go, and then we'll be done, and we will start moving towards our closing ceremony. So over to Presec Legon. Presec Legon. Presec has been with us, I think, one of the last two. Yes, one of the agriculture challenge they joined online. So Presec, over to you.
Good day, judges. I'm Nanayao. I'm Bozabu Dudakwa.
Folikuma, Senanu Yo.
Kwati, Ellis Ninkwati. Okay, so imagine you being a farmer, then you sow some seeds, then after the harvesting period, you don't get the results you expect. So introducing the farmer's assistant. So the farmer's assistant is a device that will be placed at vantage points of the farm. So the device will gather data, then run it through an algorithm that will be able to give you this, that will be able to suggest crops to plant, and it will be able to give you tips on how to maintain your farm.
By now, some of you will be wondering, why would I like to get a farm monitoring system or something that will assist me if I am a farmer? So I would like to enlighten you guys on the farm monitoring system, the benefits you are going to get from this farm monitoring. So the benefits of this farm monitoring system to the farmer is its increased efficiency system. So we are using the temperature sensor and other sensors here. So these sensors will be determined by the farmer, but since we've incorporated it into our farm monitoring system, the farmer will have more time to increase crop yield and then think more about increasing the productivity of his farm more than checking out the soil moisture, the temperature, and those. Yes, and it comes with this simple design, making it easier to install in various parts of the farm. And it also has an offline functionality, whereby the farmer at any place where he or she is without internet connection will be able to access it on his phone. This that I'm talking about is about the remote control system, where the farmer can be at any part of the world and they will be able to know what is going on his farm. Moving on to the financial projection of this, to set up this, it will take about 2,000 Ghana cedis to put up all of this. And also, we are going to market it to small-scale farmers and large-scale farmers. So it doesn't matter if you are a gardener at your small home, you can get this to help you.
So moving on to how the device works. So as you can see, the body is aluco board, and it has this ridge to protect the vital items against environmental conditions like rain, then other ones. So this is the solar controller together with the solar panel. Harnesses the solar power to charge everything up here. And we have the switch to turn on and off the solar panel. So we have multiple sensors like the MQ35 air sensor. We have the temperature and humidity sensor and the soil sensor. So basically, this device gathers data to run it through an algorithm that will determine the type of crops to produce and the tips on the farm. So let's move on to the website for the app. So the website, the homepage, it has a forum where farmers with the device can interact and share their problems involving farming. And it also has a latest news section where farmers will be updated on the current news in Aggrey, like drones being in Aggrey, then other stuff. So that's basically the homepage. And this is the dashboard, which gives you the humidity, the temperature, the air quality, the soil moisture, and the luminous intensity. So it gives you the humidity, the temperature, the air quality, the soil moisture, luminous intensity. So we are suffering from fluctuations of the humidity and the temperature. So right now, we programmed it such that there are strict conditions that it has to face. So right now, if the soil moisture sensor is in the ground, the other conditions are not met. So it will not be able to display the crops, suggestions, and the tips because the other conditions are not met, like the LDR and the other stuff. And to make it further, we have to train it more so that in such conditions like this, there will be particular types of crops that need such environment to grow. Yes, so I'll hand it, so that's for the website part.
Were there any challenges, you may ask? Of course, we encountered some of them. One main one was that in our aim to build a web app for our farm monitoring system, we decided to use the chance for our local farmers to understand the data that we will display by enabling them to translate from the English language into their various respective native languages. But along the way, we suffered in getting certain data since our local languages are not too well developed for the APIs to translate them. Also, we also wanted to implement a system such that in case the farmer may not be able to access the web app, he will have the ability to view some of the farm metrics via the LCD display, which is located around here. And as he mentioned earlier, we also have some fluctuations in the temperature and humidity readings due to the poor quality sensors we have here. Thank you.
So moving on to the uniqueness of this farm monitoring system. The uniqueness that differentiates our farm monitoring system is its ability to suggest crops for the farmer. So it's going to assist the farmer. You have bought a new land and then you want to farm on it. It will help you on the crops to select to plant on your farm. In summary, I'll urge you all to join us in promoting sustainable agriculture. Thank you.
Thank you, Presec. So you've been able to show us your control area and where your solar panels. What's in the box? Can we see? Yes, please. Be careful. But there's a lot of big space for nothing, or?
Included all the systems here.
Right.
In order to reach the sunlight, that's why we made it that high, because of the LDR here. That's why it's that long. But in normal case, it should be short. It should be because it's just a small.
Right, okay. Any questions? Please give it up for Presec. They're not good, so. All right. Okay, all right. So we're moving on to Our Lady of Grace Senior High School. Our Lady of Grace are not new to Sci-Tech Challenge, so we'd like to welcome them back. So over to you.
Good evening, ladies and gentlemen, panel of judges. Imagine a Ghana where agriculture thrives. Imagine a Ghana where farming and technology converge to create a sustainable future. Now, wouldn't that be a Ghana we would all like to live in? However, climate change and unpredictable seasons threaten the very foundation of this nation's economy, agriculture. As we gather here today, I would like to highlight a few, yet critical roles agriculture plays in our nation's economy. 1, it employs over 50% of our nation's workforce. 2, it contributes to about 20% of our nation's GDP. However, there are alarming statistics to show the need for innovation in our agricultural system. Research by the Ministry of Food and Agriculture showed that farmers who use weaker seedling results in up to 40% reduction in their crop yield. Also, the Ghana food policy showed that the one reason for reduction in crop yield is due to poor quality seedlings. To take my school, for example, a few years ago, we decided to start a school farm. However, the farm was not able to flourish because our seeds were not able to sprout. So when we were admitted into the school and we realized that problem, we decided to think about a way to revive the school farm, and then we came about with a solution. Now, taking Ghana into consideration, what if I told you we standing here have the solution to the problem Ghana is facing right now? Ladies and gentlemen, my name is Mamlanka Pagano, a proud student of Our Lady of Grace Senior High School, situated on the western hills of Mamponting, Ashanti region. I am here to present to you the solution to this project, and that solution is Garden X. So Garden X is an innovative solution designed and built by we students of Our Lady of Grace Senior High School to help address agricultural challenges faced by our farmers by integrating cutting-edge technology into our farming practices. Garden X simply aims at improving crop yield by producing high-quality seedlings. How does this system even work? Well, Garden X is a combination of smart systems, automations, and sensors. It provides optimal environmental conditions such as temperature, soil moisture, humidity, and also it has a system to adjust the irrigation. So at this point, I'm going to give it over to my colleagues to give you detailed information about Garden X. Thank you.
Good evening once again. My name is Joseph Afo. I'm here to represent Olag. I'm presenting on the structure of Garden X. Garden X has a dimensional length of 150 centimeters, width of 52 centimeters, and breadth of 35 centimeters. We've installed nets around Garden X to improve ventilation in the system. We've also installed ties to make it very mobile, which means it can be moved anywhere. When you look inside the system, you see that there is even spacing to improve easy accessibility of seedlings. All right. Garden X is divided into two parts: the farm section, which we term as Garden, and the circuit section, which we term as X, which brings up the name Garden X. The main idea is to leverage on emerging technologies to solve the problem of unhealthy seedlings in agriculture. Thank you.
Okay, hello. So I'm Ifia from Poma Ifia Dankwa, and I'm here to talk about the circuitry of garden eggs. So as you can see inside here, garden eggs is made up of different compartments, which has a lot of soil. We have a basin here, and then when you look at the side of garden eggs, you can see a lot of wires, and then these wires are connected to our humidity sensor to measure the temperature and humidity of the whole system. We also have our soil moisture sensor, which measures the soil moisture content in every compartment of soil. And then we have some of the wires connected to our water pumps, which pumps water to our sprinklers to the soil anytime it's dry. When you look at the front here, we can see that there's a lot going on here. So you can see our LCD screen, 3 push buttons, and a few LEDs over here. So this LCD screen is to show the various readings that the various sensors are reading in the farm system. So we have it's supposed to display the readings, but due to some general technicalities, we weren't able to display the information. But we have a way that we will read our information, and I'll show that to you later. We also have our push buttons here, and these ones are for the manual operation of garden eggs. So assuming I want to manually turn on my water pumps, my lights, I can just press this and then it will turn on. So a quick demonstration on how to turn on your inside light manually with the push button. So pressing this push button, you can see that the lights are on. And then these lights are to serve as a sunlight simulator for the seedlings as they germinate. And then we can turn it off by just pressing on it. And then pressing this push button, we can see that the water pumps are also pumping water. As you can see, it's pumping water to the soil. Yes. Ew. So, sorry. So somebody may ask, where did we make all of these connections? Well, we have our control box here in the back, and as you can see, we have a 4 electromagnetic relay module here, a few jumper wires, we have our data cable, and then our microcontroller. And for this project, we use the Arduino Uno board. We also have our ESP32 here as our Wi-Fi module. We also have in here a Bluetooth module for the online and offline operation of garden eggs. We have in our battery cases here, and then the connections for the other components. So the Wi-Fi and Bluetooth module are for the online and offline operation of garden eggs, as I said. So let's take the Wi-Fi module, for example. In case you are not close to garden eggs, but I want to know what is going on in your system, we have a way that you can access everything. So even though we don't have our LCD screen displaying the information over here, we have our cloud here to show you what is going on. Chrome here. So as you can see, the temperature is reading 25 degrees. We have our humidity 72%, and the soil moisture is 1,000. Yes. And we didn't really put in yes. What is the standard use of? Because I don't know. Yes. And then for the Bluetooth, we have it for offline operation. So in case you are close to garden eggs and you're in a 10-meter range away from it, you can just connect it to your Bluetooth, and then you can operate it using this app that we created. We identified some problems with the app when we were testing it out, and then we're only able to fix it with turning on only one pump. Yes. So I don't know if I can turn it on. It's not connected. Here. So if it's able to connect to it, we can show you how the Bluetooth module also works. Yes. We did all these things and made it an IoT system in order to make a person access all the information from garden eggs, and then it also can lead to economic development in Ghana as well as food security. Thank you.
So, what are some benefits of garden eggs? Garden eggs seeks
Yes, please.
So garden eggs seeks to enhance crop yield by producing high-quality seedlings to help farmers have a head start in their farming season. It also seeks to empower our local farmers. Right now, many people are not really interested in farming because of the disadvantages of it, because you plant and your crops will not grow. But garden eggs seeks to help address that problem. It also seeks to lead to economic growth. In the near future, we plan on setting up a company or a factory to produce more garden eggs to help our farmers to have higher quality seedlings. So in the near future, we hope that we will be able to partner with the Osikeni farm so that as we are producing higher quality seedlings, they'll also be using their project to help the seedlings to continue to mature so that eventually Ghana will be the Ghana that we want it to be. Ladies and gentlemen, panel of judges, together join us as we revolutionize agriculture in Ghana. This is the future of agriculture in Ghana. Garden eggs, healthy seedlings, food everywhere. Thank you.
So how much does this cost?
Okay.
Hold on, let me finish. How much does it cost? How many seedlings would it produce? And what does the bottom line for if someone wants to take this as a business and produce seedlings and sell to farmers? What does the financials look like?
Okay, so depending on the model the person wants, you can have a garden eggs as affordable as 1,000 Ghana cedis. It doesn't cost much. And also for the seedling quantity, you can plant up to 20 to 30 seedlings inside. That's depending on the size, the length of the garden eggs. Yes.
Is that including the electrical equipment as well? Altogether, 1,000 cedis?
Yes, please.
That's how you make money, Anna.
We seek to make it affordable so that it can be, everybody can have access to it.
Mother Teresa, okay. All right, so please give it up to Our Lady of Grace. And the last but certainly not the least, first in the Sci-Tech scene as well, welcome Armed Forces Senior High Technical School.
Thank you, madam.
Over to you.
Good day, ladies and gentlemen. I am in the person of Adakwa Blessing Tebua from Armed Forces Senior High Technical School, and I'm here with my colleague.
Obin Gideon. J. Dixon.
The earliest evidence of irrigation system comes from the ancient civilization in Mesopotamia, Egypt, and the Indus Valley, around 4,000 to 3,500 BC. These early systems used simple canals, dams, and reservoirs to divert and store water for irrigating their crops. According to the Ministry of Foreign Affairs and Regional Integration in Ghana, agriculture accounts for 1/4 of the GDP and also employs half of the workforce. Also, the services sector accounts for 50% of the GDP. These sectors depend mainly on rain, which makes it sensitive to climate change and unpredictable weather patterns like the drought. With this problem at hand, the country invests much in the importation of crops, since a lot of the crops are withered and be destroyed. According to Asari et al. Study on small-scale irrigation system in Ghana, they discovered that crop water waste decreases by up to 30% and increases crop yield by 20%. Also, Owusu and Yameches looked into the use of sensors in irrigation and saw that crop performance increased in areas with limited water sources. These findings suggest that automated irrigation system could help Ghanaian farmers in using water more wisely, increasing their yield, and also making farming possible in dry areas. I'll hand it to my brother to take us through the methodology. Thank you.
Thank you. So, looking at our prototype, diving through the methodology, we have components like our source of water, our poly tanks, our fertigator, our windmill,
our control box, and our solar panels. Looking here is our source of water. So looking here, the source of water, there's a pumping machine inside the source of water. So here, the source of water we are using here is a well, or you can prefer to use a borehole. Others may prefer to use rivers or lakes, but I would advise you to use a filter, whereby the filter is going to filtrate or is going to remove any solid substances that are going to create blockages inside the pipes of our irrigation system. So whilst the pumping machine is pumping water from the source of water into our poly tank, whilst the pumping is taking place, we have a water level indicator here. So as you all know, the poly tanks we use in the house, we cannot see through. So therefore, it is advisable to use the water level indicator. So as you see, here is the neutral mark, here is the minimum, here is the medium, then here is the highest mark. So immediately, the water reaches the minimum mark, then it will start pumping water. Immediately it reaches the highest mark, then it will put off the pumping machine, which is making it automatic. Looking here, we were supposed to have a timer, which is here, but it was not provided, so we had to therefore improvise to form our own local timer, yes, with some components. So looking here, we have a pumping machine here, then here is our fertigator, all connecting to one hole. So here we have it. When it is time for irrigation, you can see we have 2 pins here, which are supposed to be in our soil, but the soil is not there for now. So when the soil is moist, we know water is a conductor of heat and electricity. Water is a conductor of only electricity, but not heat. So therefore, it is going to conduct these 2 pins. Then it will send a signal to the control box to put off the pumping machine here. So immediately the soil gets dry, then it will send an information to the control box to put on the pumping machine. Then here, our fertigator. Someone will say, maybe I want to put soluble fertilizer on my crops. So looking here, someone will say, okay, let me put the fertilizer here. And some fertilizers are corrosive, others too are acidic, so they can create blockages or scales in our pipes. So therefore, we have our fertigator here. So when the fertilizer is mixed, then the farmer is ready to pump it. So there is a manual switch there. He puts on the manual switch, then it puts on the pump here, then here to get on. So both will come here, then it will mix. So here we are using the drip irrigation method. And this is better than other irrigation methods, because looking at the sprinkler methods, let's say for instance, there is a sprinkler here, so it's going to sprinkle on all our crops. And there may be weeds in the crop. So that means that all the weeds there are also getting water to grow. But looking at the drip irrigation, maybe the plant is here, the plant is here. So the water is only dripping under the crop to prevent other weeds which can be found in these spaces from getting water. Then that will also decrease the labor of the farmer from going to weed and whilst he have other programs to do. So looking here, the drip irrigation method was advisable to be used. One thing about our prototype is that it uses 2 renewable sources of energy, which is the solar panel and the windmills. As you know, our seasons in Ghana, there may be some days where the sun may not shine. So therefore, our windmill will work. So as you can see, there's no wind here, but because the AC is blowing, it's turning the windmill, the turbines of the windmill around. So as you see, there is no sun here, but the windmill is working, which will be generating electricity for storage in our battery here.
Our project certified 4 of our SDGs. That's the SDG number 2, zero hunger, SDG number 8, decent work and economic growth, SDG number 12, responsible consumption and production, and SDG number 15, life on land.
Okay, so to conclude, we say our prototype is cost effective, it doesn't cost much, and it's easy to use. It doesn't need any mobile phone operation or any, so the farmer just comes to the farm, puts on the control box, then the sensor will sense whether there is enough soil in the crops or the moisture content in the crops is less. So therefore, irrigation can start. So to reduce the labor of the farmer in the farm. So therefore, this will decrease it so that the only labor the farmer will be doing is to harvest plants, then the irrigation will be going through. Yes, thank you.
So let's take final questions. Any questions from the audience? Any questions? Any questions?
So at what point was the fertigator going to be filled?
The fertigator.
Using your manual timer.
So please, the fertigator here, maybe the farmer wants to mix the chemicals or the fertilizers. So he knows, looking at the fertilizer, there is a label on it that shows that maybe when you take 1 cup of the fertilizer, there is this amount of water that you are supposed to put in. So therefore, he pours it in, then he waits for it to mix, then there he puts on the button in the control box to allow the flow of water, then the flow of water to from the tank here, so that they will mix. Yes, please. No. Here is supposed to be raised in this form so that both of them will come at the same time. So when they reach here, then they will get mixed. Yes, to allow the flow.
So the mixing doesn't happen in there?
No, please. So the mixing happens? Yes, please.
So how do you ensure that you have the right quantity?
Yes.
So let's say, for instance, you have the fertilizer, you're supposed to do 3:1, 3 parts of water to 1 fertilizer. How do you then ensure that you have the right mix?
So, looking at that, we did an investigation on the pumping machine. So it was analyzed that the pumping machine pumps 4 liters of water per minute. So looking at that, when you measure the content of the fertilizer, you mix it here, then you put it in a ratio form to see where or the amount of water that's supposed to go through the minute or the time. So when the time is up, you just go and put it off.
But that will be the timing of the water. What about the release rate of the fertilizer?
Okay, so looking at the release rate of the fertigator, they are all using the same pumping machines. So they are all pumping the same flow of water. They are all pumping the same amount of water per minute. That is 4 liters of water per minute.
How do you ensure that the fertilizer is mixed properly in the fertigator?
Okay, so I'll advise the farmer to use a mixer. Yes, and a device that will be used to mix the fertilizers in the fertigator.
All right. No, thank you so much. I think maybe you may want to consider that at one point, the same way you may have a timer on your water pump, you want a similar timer on your fertilizer. So you can regulate how much it comes out, then hopefully you ensure that mix. Yeah? All right. Yes.
So one issue with drip irrigation is a slope.
Yes, please.
Right? And the rate of water through the vertical side and then the horizontal side, usually the rate is not the same.
For this side, please, for this side, there are no holes here.
Yes.
So they are only in there.
Yes. So water is coming from here through the vertical side,
yes,
and then into the horizontal side, right? Yes. One challenge with drip is, depending on the slope, that the inclination of the pipe, the rate of water will not be the same for the first and the third. So if you are using the system to apply your fertilizer, then you'd want to be sure that whatever modifications you need to make the system to guarantee that the same quantity of fertilizer is reaching all of them. You'd have to research and then figure out a way to manage that. And even the watering itself, right? So, because this is on a flat surface, but typically you don't have a flat surface, right?
Thank you.
All right.
You also mentioned the water and conducting relative to the 2 nails as a trigger for the drip to begin, right? Maybe in the future you can consider maybe a moisture reader instead of the nails. Because
we're supposed to use the moisture reader, but because we didn't get that, we had to improvise to create our own moisture
so this
sensor.
is improvised?
Yes.
Which
so
would,
we've
okay, I
created
get
that.
it now.
Thank you so much. Please give it up for everybody. And give it up for all the schools. It's been amazing. I think every year, year on year, the solutions are different and we're getting even more better solutions. So give it up. Give it up for all the